Okay, so in this video we're going to look at simplifying radicals, and that's we've been doing this for a couple weeks, Landon, so I just want to make sure you understand that anytime you have a number underneath a radical sign like this, you can take it and break it down into different factors. For example, you can separate out the products here. So if I was wanting to simplify this, I'm just going to start by showing you that I can break this apart. I can say that that's 10 times 5. Still equal to the square root of 50. Can't simplify this at this point. So let's think of another set of factors. And this is very strategic when you're thinking of factors. You want to try to think of numbers that are perfect squares. What I mean by perfect squares is a number times itself. So this 25 is the same as 5 squared. Squares and square roots are inverses, so they cancel each other out. So I can just go through here and erase the square and the square root symbol, and it's going to equal 5. This piece here can't do anything with, so I need to just write it down. So there's your final answer. Okay, 45, if I break 45 up into different pieces, this is just to show you that it's perfectly legal to do this. 3 times 15 is 45, but this doesn't help me any. So in this number, there's a perfect square embedded in it, and that number is 9. And 9 can be written as 3 squared. And now the square and the square root cancel each other out. So you're just left with a 3. See, we can take this off right here. The square and the square root cancel each other out. Okay? And so our final answer is equal to 3 times the square root of 5. All right. Then we had a few questions like this. And first of all, I wanted to explain that the operation that these two are speaking to each other is multiplication. So you don't have to have that multiplication symbol there, but the implication is that it's 3 times the square root of 16. Well, we know the square root of 16 is a perfect square. And we know that